Our last House of Dauphine startup is Renewable Energy. We will hear from Kemp Gregory. Kemp is our resident Longhorn and voted least likely to believe that leaving well enough alone applies to idle oil wells. I can now see you and your slides. You're good to go.
Happy to be here. What you were looking at is an inactive well that was drilled in California's Central Valley in 1992, then produced valuable oil for decades, but not a drop in the last 2 years. It is waiting to be plugged and abandoned, an expensive process that fills the well with cement, removes all surface equipment, and tears down the power lines. Shouldn't we be able to put all of this valuable infrastructure and inactive wells to a new use? Because there are hundreds of wells just like it in this field, 50,000 like it in California, and over 2 million like it in North America. To further understand the problem, it is important to know that oil and gas companies are required to remediate every single well they own. These remediation costs can vary between $10,000 to $500,000, but are always a zero return investment, and these wells can be polluting locally and atmospherically. We offer a better choice: to convert an idle well into a gravity well. Renewell is currently testing our patented prototype built from off-the-shelf equipment, which stores gravitational potential energy by moving a weight up and down the wellbore, similar to how pumped hydro works. Our technology creates compelling conversion benefits for the oil and gas company and the environment. The energy storage features include a lower capital cost than lithium-ion by its projected 2025 cost, and the flexibility to participate in the most energy storage revenue streams on the market. It's important to understand that energy storage is required for renewable growth. Today's wind and solar capacity is sparse and supported by 284 gigawatt hours of energy storage capacity. In 2050, the wind and solar capacity will grow to this, supported by an estimated 1,300 gigawatt hours of energy storage. Inserting the inactive wells onto this map, you can see the fortuitous overlap. This infrastructure could be converted into 78 gigawatt hours worth of capacity by 2050. Now, Renewell estimates we can repurpose somewhere between 10% and 30% of all idle wells. But let's say the actual number is close to 20%. That still represents $58 billion of collective idle well liability. It is this money we are trying to get in front of and offer a better purpose for, using it to unlock the burgeoning energy storage market, which Renewell estimates could be a revenue stream worth $3 billion by 2030 from a projected 24% of the market share. Renewell has solid traction represented by 2 pilot wells lined up. The first will be in Texas, completed by Q4 with Rife Energy, and the second starting in Q1 with Era Energy in California. In the midst of the California pilot well, we'll be raising a $3 million seed round. We will hire 3 engineers, mechanical, software, and electrical, and then begin the iterative design and build process for our minimum commercial product. Because we are a distributed energy storage technology, the next major milestone is achieving the remote and collective control of all of these MCPs. Renewell has a powerful team delivering results today. The 3 co-founders are myself, bringing experience as a petroleum engineer with Shell, Stefan Streckfus, whom I met during our time as graduate students at Stanford, and who brings experience as a lead engineer with Burger King commercializing industrial equipment, and Walker Colt, who is a petroleum engineer with degrees from Texas A&M and Rice Business School and 8 years of oil and gas experience. We have also assembled an impressive team of advisors to increase speed and effectiveness. We invite you to have a conversation about investing in Renewell to accomplish our next milestones. Thank you very much.
And thank you, Kemp. Let's turn it over to our attendees for questions. We have Walker Colt also joining Kemp on the Q&A portion. So first question, what is the competitive advantage of your technology over other energy storage technologies?
It's a good question. This table summarizes that in short. Here you've got on the top axis a comparison to technologies with some of the more recognizable brand names below them. But essentially, the one we'd like to emphasize the most is that our environmental benefits. We claim that we are the only net negative energy storage device out there because we can seal up these wells and prevent more methane from leaking than is embodied in the equivalent energy necessary to build our device. That means for every gravity well that's installed, it's having a net negative impact on the amount of CO2 in the atmosphere.
All right. Question from Vincent. How is the energy stored? Is storage of like a transient green energy? How is it restored?
So it's a mechanical device. When the weight is at the top of the well, it's got a bunch of potential energy. It wants to descend down that well. When it comes time to discharge, we control its descent and then use a regenerative winch on surface to convert that potential energy into electrical energy and put it back into the grid.
Next question. What is your revenue model?
The revenue model will be a combination of energy storage revenue streams. So that's the most frequently cited is energy arbitrage, so buy it low, sell it high, as well as a various combination of ancillary services, which is us basically getting paid by the utility or the balancing service to help run the grid. These are frequency regulation, resource adequacy if you're in California, and a handful of others. And what makes Renewell so interesting is that we can combine so many different revenue streams in the same device.
Kemp, what is the useful lifetime of your Renewell?
That's another good question. The timeline that we anticipate for the useful life of any given Renewell is somewhere between 25 to 30 years.
Okay. Question from John Jeffers. How do you handle the environmental risk associated with these legacy wells?
That's a good question. When we go to convert a well, Renewell will handle all liability associated with the damaging of the well that is our fault, that happens during our installation or operation. But the final plug and abandonment liability will stay with the oil and gas company.
Question from Jim Allman. How much energy can be stored per well? Using what weight? Through what distance?
I wish there was a quick and easy answer to that question. It's mostly it depends, simply because the idle well population is so varied. Wells can be 3,000 feet deep or 15,000 feet deep. They can have 5.5-inch casing or 9-inch casing. But generally, to put bookends on it, we're talking about something like 25 kilowatt hours to up to 200 kilowatt hours per well.
Thomas Henry asks, what is your IP for this technology?
Another good question. Thank you, Thomas. We have 4 patents pending for our technology, and those should be converted sometime early next year.
A question from Derek Adams. Are you assuming all liabilities from the original well owner?
So I think embedded in the question is sort of the idea of who owns the well once we convert it, and the well will stay the property of the operator of record. So if that, company XYZ always owns the well. We just rent the well from them. That rental payment is either something we agree upon or a cut of the energy storage revenue stream. I hope that answers the question.
Hopefully so. Next question from Hani. When you say seal up the well, are you first securing the well, eliminating any sustained annual pressure, replacing in-well jewelry, or are you using as is? And does the well have to be empty, or it can be full of fluid, etc.?
Yeah, really good question. Okay, so for any given well, the average is going to have tubing and a pump jack on it, let's say. To remove that tubing and the pump jack is a zero incremental cost to the oil and gas company. They have to do it eventually. So the agreement thus far is that they prep the well, which means pump jack away, tubing away, and seal it at that lowest reservoir or shallowest reservoir, and then sort of turn it over to us with a well bore full of whatever fluid was in there. And then we flush it out so that we have control over the fluid that this weight is going to be operating within. And then that's the operating profile that we anticipate going forward. So it will be in fluid the whole time.
All right. And then the last question from Ashok. What's the CapEx for retrofitting a well with this storage mechanism?
It's a moving target, and we're working on designing that minimum commercial product, which will be representative of sort of our first capital expenditures for our first product. And we have a pretty good idea of how the economies of scale are going to impact this, but you can estimate something like a couple $100,000 for the capital cost of conversion. And then we hope to come down pretty aggressively into the sub 100,000 range.
Okay, thank you, Kemp and Walker and Stefan. There are additional questions in the chat. Feel free to address those during our break. I want to thank everybody within the House of Dauphin pod. Thank you, Kevin, Liz, Sizway, Gachang, and Kemp. We will now take a brief 2-minute break, and when we come back, we'll hear from Mike Evans.